Assalamualaikum and good morning, everyone.
Waalaikumsalam, sir.
Good morning, sir.
Okay, thank you. All right, so today we will discuss tutorial number 4, and we will look at some other configurations for rotational system with gearing. So let's look at question number 1. So question number 1, find the transfer function theta 2 over tau A for the system below. Okay, so this system is rotational system without gearing. So it should be a straightforward system that you can directly derive without having to use any gear ratio or impedance transfer. So let's do this. Okay, so let's look at body J1, okay, or theta 1. Okay, so on J1 there is a spring KR and also a damper BR1. Okay, so there's a spring KR and also damper BR1, and there's a input torque tau A. Okay, so let's draw the forces or the torques on the free body diagram. Okay, so first is the spring. So we have spring KR theta, KR theta 1, and then the damper BR1 theta 1 dot. And then we have the torque. So the torque is in clockwise direction, the input torque. And also we need to consider the inertia. So we have J1 theta 1 double dot. And then the damper BR1 is also connected with J2. So we have to consider the effect or the torque from J2. And this torque is counterclockwise, okay? So we have BR1 theta 2 dot. Okay, then we can write the equation of motion for this one. So we have J1 theta 1 double dot plus BR1 theta 1 dot plus KR theta 1 minus BR1 theta 1 dot theta 2, sorry, equals tau A negative. Okay, then we can write in terms of frequency. Okay. Okay, now let's look at the second shaft or second second body. Okay, so on J2 there is a damper BR1 and a friction BR2 with the floor. Okay, so we have the torque BR1 theta 2 dot, and then torque BR2 theta 2 dot from the friction. And then we also have the inertia J2 theta 2 double dot. And then BR1 is also connected with J1. So we have the contribution from J1. Okay, so we have BR1 theta 1 dot counterclockwise. Then we can write the equation of motion. Okay, then we can write in terms of frequency. Okay, then we have two equation here. Then we can write in matrix form. Okay, so the question asks you to find theta 2 over tau A. So theta 2, basically you just find the determinant of this matrix by replacing the second column. Okay, second column with the input column. Okay, so this one is the first column. So just replace the second column divided by the original matrix. Okay, so later on, you can try to simplify the determinant to find theta 2 over tau A. Okay, so the process is similar with um, translational mechanical system. Okay, so now let's look at the second question. So the second question, find the transfer function theta 2 over T for the rotational mechanical system above or below, okay, below. So we have T applied on the first shaft here, and then this shaft is connected with a spring and damper to this point, and theta 2 measure the rotation of this point, okay. And then this point is connected with a damper and spring to wall. Okay, so this is similar to translational mechanical system in previous tutorial, in last week tutorial, where when I show that when there's a connection between, let's say, spring, connection between two spring that is in series. So when two things are connected in series, then the point in between them has a degree of freedom. Okay. So similar to this one, these two arrangements, spring and damper, is connected in series with spring and damper, another spring and damper. So the point in between them has a degree of freedom. So this system is actually a 2 degree of freedom system. So 1 degree of freedom is measuring this point, and then another degree of freedom is actually measuring the rotation of the shaft. But in the question, it doesn't show to you theta 1. So you have to introduce by yourself, okay, theta 1. So let's do this. So let's draw the free body diagram for theta 1. Okay, so we have torque T in clockwise direction. And then on theta 1, there is a spring and a damper. Okay, spring 1 Newton meter per radian and a damper 1 Newton meter second per radian. So we have two force or two torque. So from the spring, 1 times theta 1. And then from the damper, 1 times theta 1 dot. And then we have the inertia because on theta 1, there is a mass 1 kg meter squared. So 1 times theta double dot, okay? And then this spring and damper is connected with theta 2. Okay, both of them are connected with theta 2. So you have the contribution from theta 2. So we have from spring, 1 times theta 2. And then from damper, 1 times theta 2 dot, okay? Then we can write the equation of motion for this one. So we have theta 1 double dot plus theta 1 dot plus theta 1 minus theta 2 dot plus theta 2 equals T. Okay, you can write in terms of frequency. Okay. Then let's look at the second theta 2, the second degree of freedom. So theta 2 basically is only a point without any mass. Okay, so there is no mass, so there is no inertia on this point. So on theta 2, we have the spring 1 Newton meter per radian, and then another spring 1 Newton meter per radian, and then two dampers similar to spring. So we have 1 Newton meter second per radian, and another one 1 Newton meter second per radian. So we have four torques from theta 2. So we have theta 2 from spring number 1, and then this is from spring number 2, and then this is from damper number 1, and this is from damper number 2. And then the spring number 1 and damper number 1 here is also connected with theta 1. So we have the torque contribution from theta 1. So we have theta 1 from spring and theta 1 dot from the damper. Okay, theta 2 has no mass, so we don't have a double dot, okay? Then we can write this, the equation of motion. Then we can write in terms of frequency. Okay, so we have two equations, then we can write in matrix form. Okay, so to find theta 2, similar to question number 1, you just replace the second column with the input force or input torque column. Okay. All right. So until here, any question?
Nak try sendiri dulu sir. Baru saya tanya balik.
Okay.
Sir,
Yep.
kenapa untuk yang theta 2 tu, dia ada dua theta 2 sir? Yang kat free body diagram untuk theta 2,
Ni.
theta 2 tu.
Okay, sebab ada dua spring. Ada spring satu kat sini, satu
Oh,
dekat
oh, oh,
belakang
yang
ni.
spring. Okay, okay. Thank you.
Okay, so question 1 and 2 is system without gearing, rotational system without gearing. So it's kind of similar to translational mechanics. Okay. So I hope by now you understand how to do um, translational mechanics and also rotational mechanical system without gearing. So now let's look at example for rotational system with gears. Okay, now we have gears. So question 3, find the transfer function theta 2 over t. Okay, so now in this figure we have gears. So we have gear N1, N2. So N1 is connected with N2, and then gear N3 connected with gear N4. And we have 3 shafts. So if we hold shaft J1, for example, if we fix shaft J1, we hold it so that it cannot move. So when J1 cannot move, then gear N1 will not move as well. So when gear N1 are not moving, N2 also will stop moving. So when N2 stop moving, then J2 will stop moving as well. Then it affects N3. N3 also stop moving, and then it affects N4. N4 also will stop moving. So this system, if you fix one of the mess, then all of the system, then overall system will stop moving. So this means that the system is 1 degree of freedom. Okay. So only one movement only. When you fix one of them, then everything will stop moving. So that's the meaning of uh, degree of freedom lah. Okay. Meaning that if you have 2 degree of freedom system, if you fix 1 degree of freedom, then the other degree of freedom can still moving. So that's the meaning of 2 degree of freedom system. But for this case, it's 1 degree of freedom because when you fix one thing, then everything will not moving. So for this kind of problem, you can perform impedance transfer as what we have learned on Monday. So another thing to consider before performing the impedance transfer is to determine which one is your destination and which one is the source. Okay, so you need to choose. Okay, so this is depends on you. If you choose J1 is as the source, then you have to transfer everything to J1. If you choose J2 as the source, as the destination, sorry, then you have to transfer everything to J2. If you choose J3, then everything must transfer to J3. So it depends on your choice, okay? And the answer in the end will be the same. But the jalan kira, the process of calculation will be different, okay? So theta 2, in this case, theta 2 is in the middle, okay? Theta 2 measure the rotation of J2. So it's better if we can choose theta 2 as the destination, okay? Because you can transfer everything to the middle and then straight away get the transfer function for theta 2. For example, if you want to transfer to J1, so J1 measures theta 1. So if you transfer everything to theta 1, then later on your transfer function will be in terms of theta 1. So to convert to theta 2, you need to perform the gear ratio conversion. So that's another additional calculation over there. So it's making your calculation longer. So in this example, we choose the middle shaft as the destination. Okay. And then shaft J1 as the source number 1. And then shaft number 3 as the source number 2. Okay, so let's calculate the total impedance by performing impedance transfer. Okay, so firstly, calculate JE, okay, J equivalent. So we want to transfer everything to the middle shaft. So the middle shaft already has J2. So J2 we don't have to transfer. So we just write J2. And then plus the shaft, the mass J1, the inertia J1. So J1 is on shaft number 1. So we need to perform impedance transfer by multiplying with the gear ratio squared. So J1 times N2 over N1 squared. So the formula is N destination over N source. Okay. Kan lupa dah. Betul ke formula dia? Okay, so N destination over N source squared. Okay. So don't forget the square. And then we have J3. So J3 from shaft number 3. So we have to multiply uh, with uh, with the gear ratio square. So time plus J3. So in this case, the N destination is N3 and then N source is N4. So N3 over N4 square. Then we can calculate the J equivalent. Okay, so we get 20 kilogram meter squared. Then similarly, we calculate for the damper. So in this case, the friction. Okay, so D1, D2, and D3 represent the friction in between the gears or in the gears. Okay, so D1 is friction for gear N1, D2 is friction for gear N2, and D3 for friction gear N4. So D2 is already on shaft in the middle shaft, so you don't have to transfer the friction. So D equivalent equals D2, so you don't have to transfer D2 plus D1. So D1 is on shaft, first shaft, so you need to transfer. So you need to multiply N2 over N1 squared plus D3. So D3 is on shaft number 3. So you need to transfer. So times N3 over N4 squared. So we get 2 plus 1 over 12 over 4 plus 32 over 4 over 16 squared. 13 ke? Entah. Okay, later on you check, okay, whether my calculation is correct or not. And then lastly, we have the spring. So K equivalent. So in the middle shaft, there is no spring. Similar to the first shaft, also there is no spring. So we only have spring on the third shaft. So we only transfer K from the third shaft. Okay. So we have K times N3 over N4. So we get 64 times 4 over 16 squared. Pi. Okay, so we have calculated all of the impedance. Then we can, it's better if you can redraw the system, okay, so that you can visualize. So we have shaft here. So J equivalent connected to a damper or friction. So similar, so we can draw the damper or the friction as a damper. And then we have spring at the back. And then the middle shaft measure theta 2. And then we need to add torque, okay? So we need to add T2. So what is T2? We need to transfer this torque here. So formula dia, sekali lagi lupa, kita tengok balik. Okay, so T1 over T2 or T over T2 equals N1 over N2. So we get T2 equals T times N2 over N1. Okay, so this is your torque T2. So from this new system, then you can draw the free body diagram. Okay, so on shaft JE, we have torque T2. And then we have a damper. So the effect of damper, dE theta 2 dot. And then the effect of spring, we have KE theta 2. And then lastly, the effect of the inertia, JE theta 2 double dot. Okay, so you don't have any, you don't have to consider the effect of J1 and J3 because they are, they have been transferred to the middle shaft already. Okay, so it's a 1 degree of freedom system. So from this free body diagram, you can write the equation of motion. Then you can substitute all of the values that you have calculated. And then rearrange to get theta 2 over t. So your theta 2 over t is this transfer function. Okay. Okay, any question for this section? Sorry? Okay, so that's for question number 3. So now question number 4 and number 5 is a special case. Okay, so when let's look at the lecture notes first before we tackle this question. Okay. Okay, so we have learned about transferring the impedance from one shaft to another shaft. Okay, so by first choosing which one is your destination and which one is the source, and then to transfer the impedance, we multiply with the gear ratio squared. So there is some cases that when you transfer the impedance, it doesn't reduce into 1 degree of freedom system. So that's why before you want to transfer the impedance, you need to determine whether the system is 1 degree of freedom or more degree of freedom. Okay. So for example, in this example given here, this is a system that has 2 degree of freedom. Okay, so the reason is because of the spring in between the two shaft here. So let's say if you fix shaft number 1, if you fix shaft number 1, you hold it, then the gear N1 and N2 will stop moving. So when gear N1 and N2 stop moving, then basically this whole section here will become like a wall, okay? Macam dinding. So when this section becomes wall, then this connection is actually a 1 degree of freedom connection, okay? Because you have spring, a shaft, and a damper. So wall in between them. It is located in between a wall, in between walls, okay? So this is actually 1 degree of freedom, okay? Meaning that this 100 kg meter squared shaft can still move, okay? Can still rotate. So it rotates, but it is restricted by the spring and the damper, but it's still able to rotate. Okay. So this is the description says. Okay. So if you stop the J shaft 1 kilogram meter squared here, the gear rotation will stop, but the shaft 100 kg meter squared still able to rotate. So what happen if you fix this shaft here? So you fix this shaft, then this whole section will become something like wall. Okay, so when this section becomes a wall, because of this spring here, the gears can still move, but the movement is restricted by the spring. Okay, so but it's still able to move. Okay, so when this is able to move, then this shaft here actually has its own degree of freedom. So here, what I want to show is that if you fix one shaft, the other shaft still able to move, and vice versa. So the degree of freedom of one shaft here is not affected by the other shaft. So this system here is a 2 degree of freedom system. So you can convert this into 2 degree of freedom system by performing impedance transfer. So what you can do is, let's say you want to transfer, uh, let's say you define this as the source and this as the destination. So when you transfer this inertia here, so you do J equivalent equals 1 kg times N2 over N1. So you get 100 N1 N2 over N1 squared. So you get 100. So when you transfer this to the destination, you cannot add to this 100 kg. Okay, but instead you add uh, the 100 kilogram meter squared here in front of the spring. For example, in this figure here. Okay, so you cannot add to this 100 kilogram meter squared because of the spring. Okay, so then if you transfer the torque, so torque, let's say T2. So T2 equals T times N2 over N1. Sorry. Okay, so T2 is T times N2 over N1, so you get 10T here. And then theta 1, you can transfer, you get theta 2. So theta 2 equals N1 over N2 theta 1. Okay, so you have to determine the number of degree of freedom first before you can perform the impedance transfer. Okay. Shh.
Aduh.
Mute.
Pening kejap.
Takut bulan puasa kan, tak tahu buat apa. Astagfirullahaladzim. Okay, so let's look at tutorial. Tak apa, pening tu lah bagus. Okay, nanti barulah study. Okay, so let's look at tutorial question number 4 and number 5. Okay, so let's look at question number 4 first. So given the rotational system below, find GS theta 6 over theta 1. Okay, so soalan macam ni, dia bukan over T, okay? It's theta 6 over theta 1. So you have to do some extra calculation, okay? So theta 6 is here, measuring the last shaft here, J6. But theta 1 is measuring the displacement of the first shaft. So here, if you transfer all of the impedance like J1, so J1, J2, J3, J4 represent the inertia of the gears. Okay? And D, the D's attached to the gears are the friction on the gears. So if you transfer J1, J2, J3, J4 and the D's, if you transfer to this section, so you nak tambah dekat mana? Tambah kat J5 ke? Tambah kat J6 ke? Ataupun semua ni tambah jadi satu J. Okay, so there are a lot of possibilities. So kebanyakan student kalau soalan ni keluar pasir, they just simply add up everything to J6. Okay, so jawapan tu completely wrong lah, because J5 and J6 you cannot add these two together, J5 and J6, because of the damper and spring, and there is no gears in between J5 and J6. So J5 and J6 are its own, okay, its own itulah its own system. So you have to either add to J5 or introduce a new degree of freedom. So before that, let's determine how many degree of freedom of this system. So we know that J5 and J6 are 2 degree of freedom. Okay, they are 2 degree of freedom because if you fix J6, J5 can still rotate. If you fix J5, J6 can still rotate. Okay, so let's eliminate J6. because we know that J6 is already 1 degree of freedom. Okay, so let's say ada wall kat sini. Kita abaikan J6 lah, okay. It's 1 degree of freedom. So if you fix J5, then gear N4 will not move, okay? Because there's nothing here compared to the example from lecture notes. There's a spring in between J5 and the gears, but here there's nothing. So if you fix J5, the gear will stop moving. So it affects J3, J2, J1. So meaning that if you fix J5, then this whole system after J5 until theta 1 here will fix, okay? Will not move. So this whole thing here, okay, so whole thing here is 1 degree of freedom. So if you transfer J1, J2, J3, J4, you can add to J5. Okay, you simply add to J5. But you cannot add to J6 because J6 is another degree of freedom. So let's do this. So theta 6 is on this shaft here on J6, but we know that J6 is another degree of freedom and J5 is also another degree of freedom. So it's better if you transfer everything to J5 rather than transferring everything to theta 1. Okay. So let's transfer everything to J5. So firstly, we have the J equivalent. So J equivalent equals J5 plus. So firstly, J4 here. So J4 is already in this shaft, J5. So you don't have to multiply with any gear ratio. So you just add J4 and then plus J3. So J3 is on N3. So if you want to transfer to J5, you need to multiply with the gear ratio. So J3 times N4 over N3 squared. Similar to J2. So J2 is on N2. But to transfer to J5, you have to multiply the gear ratio N4 over N3, not N4 over N2, because N2 is not connected with N4, but N4 is connected with N3. So plus J2 times N4 over N3 squared. And then lastly, we have J1. So J1. So firstly, J1 is located here. So you want to transfer to J5. So dia jauh gila nak pergi J5. So before it can reach J5, you must transfer it by multiplying N2 over N1. Okay, transfer dia satu-satu dulu lah. One by one. So you transfer J1 to the middle section. You multiply N2 over N1. And then when you have transferred it to middle section, to transfer to J5, you need to multiply again with N4 over N3 squared. Okay, so dia dua kali gear ratio. Okay, so this is the J equivalent. Now let's calculate the D equivalent. Okay, so for the D equivalent, if you look at this D here, the damper here at the end shaft, this D is connected with J5 and J6. So if you transfer all of the D from the gears to J5, you cannot add to this damper because this damper is connected with J6. But differently, so differently from J, you can add to J5 because J5 is not connected with J6. Okay, tetapi damper D here, the D damper here, and the spring K2 here is connected with J6. So if you transfer the D's, you have to introduce a new damper, okay, a new damper. So the new damper DE equals D. So the D is this D. Okay, this D you don't have to transfer because it's already on the shaft J5 or on the gear N4. So you have to transfer this D. So to transfer this D, you have to multiply N4 over N3 squared. So plus D times N4 over N3 squared. And then you have one more D here on J1. So here again, similar to shaft J1, you have to multiply by 2 gear ratio. And then lastly, the K equivalent. So similar to damper, you cannot add to K2. So you only transfer this K1 here. So K1, you multiply with N4 over N3. Then let's redraw the system first before you find or draw the free body diagram. So we have J equivalent here, and then a damper, a spring, and these are connected with J6. Okay, so on shaft JE, we have the damper equivalent. And then we have the spring K equivalent. And then we have theta 2 here. Okay, so we have theta 2, but the question wants theta 1. So we have to convert theta 2 in terms of theta 1. So theta 1 over theta 2 equals N2. Sorry, ini formula N2 over N1. But theta 2 is here, theta 1 here, so you have to multiply by the gearing, okay? So we have N2 over N1, and then multiply by N4 over N3. So theta 2 equals N1 times N3 over N2 over N4 theta 1. Okay, punya panjang dalam kira. So now you have transferred everything. So you can draw the free body diagram of this system. So I leave it to you, okay, to draw the free body diagram for this system. So it's a 2 degree of freedom. So you have one free body diagram for JE and one free body diagram for J6. Okay, so you have theta 6 here and theta 2 here. So your equation later will be theta 2 something something plus theta 6. So this is also theta 2 plus theta 6 equals T equals 0. So arrange in matrix and then find theta 2, then find theta 6, and then find theta 6 over theta 2 or theta 1. Okay, so you have to find theta 2, theta 6 dua kali kira. then find theta 6 over theta 2. You can show me to check, okay? Check your answer. I don't have the answer, okay? So that's for question number 4. So sikit lagi. So let's look at question number 5. So in question number 5, we have theta L. We want to find theta L over T. So theta L is on the last shaft, but T is in the first shaft. So we have the middle shaft here. So if you look at the middle shaft, let's look at middle shaft first. So we have spring and damper connected in series. So what I said earlier, if you have connection in series, the point in between them has degree of freedom. So here you have to introduce your own degree of freedom. So here, let's introduce theta 2. Okay, there's a degree of freedom in between two things that connected in series. And we have theta 2 here, and maybe shaft T, we have theta 1. In this system, it's slightly weird because there is no inertia. Everything involves point, so you don't have mass, which is easier, okay? You don't have to consider the mass. Okay, so what to do now? So we have theta L on the third shaft. So if you refer to this tutorial, question number 3. Destination. So usually we decide the destination based on this question theta 2. So we decide theta 2 as the destination. But in this example, in this tutorial, theta L is here. So if you choose theta L as the destination, then you have to transfer so many things. You have to transfer this spring, this damper, torque, theta 1, theta 2. Banyak gila nak transfer. Okay. So it's tedious to do that. So another, to make things easier, you can transfer everything to the middle section. Sebenarnya sama je, tapi transferring to middle section, I think will produce a simpler answer, okay? Simpler calculation. So before you transfer, let's determine the degree of freedom. How the system behaves if you fix one point and so on. So let's say if you fix theta 1. So if you fix theta 1, then this whole system here will become wall. So N1 will not move, so as N2 also not move. So ni macam wall jugalah. So we have spring here. So the spring here will cause theta 2 to move. So the wall is until the spring. So this theta 2 can move. So as theta L also can move. So when you fix theta 1, theta 2 and theta L can move. Okay, there is 2 degree of freedom here, theta 2 and theta L. Okay. So let's say if you fix theta L, so this whole part here becomes a wall. Then N4 and N3 will stop moving as well. So this part here also becomes wall, okay? This part onwards, okay? Jadi dinding. But because of this damper, theta 2 can move. So theta 2 can move, so as theta 1. So there is a 2 degree of freedom here if you fix theta L. So if you fix one thing, there is still 2 things moving. So here the system is actually a 3 degree of freedom system. Okay. So for example, in previous example, like in this example, question number 3, if you fix J1, everything will stop moving. So meaning that there is 1 degree of freedom system. So, but in this case, if you fix theta 1 or theta L, there are still 2 things moving. So 2 things moving plus the things that you stop moving, you make it stop or you fix it, meaning there are 3 degree of freedom system. So I will redraw the system, but I want you to later try on yourself, on your own, to find the J equivalent. Okay. So the system, if you choose the middle part as the destination, then the first section becomes the source number 1, and then the third section becomes source number 2. Okay, so we can transfer everything to the middle section. So the system will be reduced something like this. Okay, so this is 2 Newton meter radian. This is 3 Newton meter second radian. So this is K equivalent number 1. So later you can find this. And then this is damper equivalent number 2. Okay, from source number 2. So the middle section measures theta 2. This section measures theta 1 or theta equivalent 1, E1. So theta equivalent E1, you have to do something times theta 1. And then the third section here, theta equivalent number 2, similar to theta 1, you have to do something times theta L. And then on theta theta equivalent 1, you have torque equivalent 1. So to find torque equivalent 1, you have to do something times torque. Okay, you have to do the impedance transfer. Okay, you have to do the gear ratio things. Okay, so that's it. Okay, so you can try later to find KE1, theta E1, TE1, theta E2, DE2, and find the transfer function. And if you want me to check, feel free to WhatsApp me. Okay. Okay, so that's it for today. Any question before we end this lecture?
Doktor.
Yeah.
Bagi question
Tak dengar suara. Lari dah. Lari dah kau.
boleh
Yes.
boleh dengar?
Boleh.
Boleh. Doktor boleh tanya yang theta 1, theta 2 tu kan, macam mana kita nak tahu dia nak letak dekat mana?
Okay, so theta 1 basically measure this rotation. Letak kat mana tu maksudnya dekat dia punya rotation ke, dia punya location ke?
Dia location.
Macam location theta tu I put it in between spring and damper. Sebab I said earlier, if you have 2 things connected in series, so the point in between them has degree of freedom. So you letaklah
Okay,
theta 2. Okay. Theta 1 measures the rotation for the first section. Okay, even though dia tak show in the question, but from our deduction just now, when you fix the things, there's actually a theta here or degree of freedom. So you just put theta 1 lah.
Okay, boleh. Okay, thank you, Doktor.
Alright. Okay, any question? So today is 6. Okay, so don't forget your part 1 project, submit before 11 midnight, okay? Meaning that submit on Sunday. jangan lambat because it's automatic lock, okay? Lambat, hantar, kosong markah, okay? And I think somewhere next week, there will be quiz number 2. Or maybe this week, I'm not sure. I think next week, okay? Will be released by Cik Osmazi, okay? I think maybe on Friday 15. So when released, I will let you know. And please get your MATLAB because you have project part 2. I think the due date is 5, 6, 7, 8. I think week 8. Okay. So we will learn for part 2, for related to part 2, project part 2, maybe somewhere on week 7. So please get your MATLAB because part 2 is a free marks. If you tak hantar, rugilah 4 markah, okay? 4 markah tapi it's so a lot later in your final carry marks, okay? Because your exam selalunya soalan senang pun tak boleh jawab, okay? So please do your assignment, your quiz and project just in case you cannot do well in your final exam, okay? So that's it for today's class. See you again next Monday, insyaAllah. Assalamualaikum and goodbye.
Thank you, Dr.
Thank you,
Yes,
Doctor.
sir.
Thank you.